Before we actually start installing the software, I want to just mention that this is a pretty short list that I've shown you, and it is by no means meant to be exhaustive of all the kinds of software you might want or need for your bioinformatics work. It's just what we can cover in this course, and there's a lot of software that my lab actually uses very frequently that we won't have time to cover, either because it's not relevant to RNA-seq transcriptomics data, or that particular piece of software won't install or run well on a laptop, or it's just frankly beyond the scope of what we can just get done in a semester. But if you're interested in looking at some of those other pieces of software, I provided a link at the bottom of the page here that you may want to explore. If you click on that link, it's going to take you to part of my lab's website where we have this kind of running list of software tools that we frequently use, including the name of the tool, the website where you can download it or learn about it, and then if there's a manuscript or citation available, a link to that as well. And we've also kind of binned these into categories depending on what that particular piece of software tool is used for and how we run it from the command line. Okay, heading back over to my slides. But we will, for the sake of this semester, focus on just this list of tools. And as I mentioned just a minute ago, we're going to just start with the first four. I'll demonstrate downloading and installing R and RStudio. And to do that, it's really click, download, install kind of process. So we'll start first with going to the R project website to download perhaps the most important thing for this semester, which is the R programming language. So when I click this link, I'll be taken to the very humble and understated R project website. And I can see this bold link here to download R. So I'm going to go ahead and navigate there. And I'm taken to a page of what are called CRAN mirrors. In the R world, CRAN is the comprehensive R archive network. It's basically where you go to download all the stuff you need for R, the R packages, R itself. And you get a sense right away for the community here. You can see that there are mirrors or downloadable locations stretched around the entire globe here. We're going to choose the first option, which is the Cloud R project. But if you're watching this video and you're in China or in Chile, you can find closer, perhaps better or more accessible sites, mirrors that you can download the same stuff that I'm going to be getting here. So I'll click on this top link. And that takes me to a page where I need to choose to download R for Linux, Mac OS, or Windows. Remember, I have a Mac computer, so I'm going to click the second link. But if you're running a Windows machine, you would want to click the third link here. And of course, Linux, the first link. So when I click on that second link, I'm taken to the actual download page. And for those of you who are also using a Mac, you'll see two versions, one for M1 chips and the other for Intel Macs. At this point in the Mac evolution, there are two hardware configurations, one that uses this ARM64 M1 chip, and the other that's still on the original or legacy Intel chip. I have this one, so I'm going to download this. But if you happen to have one of these newer M1 chip Macs, you'll want to download this top one. I'll also mention that in addition to the version number, which as of the recording of this video is 4.2.2, R also gives itself, each version, a nickname. In this case, the nickname is Innocent and Trusting. Sometimes those nicknames are easier to remember than version numbers, and I think, at least rumor has it, that those nicknames are pulled directly from Peanuts comics. Now, if you're watching this, you may see a different version number here. You may be watching it 6 months from now or a year from when I've recorded this video. It doesn't matter. Download the most current version, whatever that is. All right, so I'm going to select this second one here. I'm going to download it. I don't care where it goes on my computer. And I can see it downloading down here in the bottom left. And it only is going to take a few seconds to download. And again, once that's finished, I'm just going to click on it because it's an installer. And it's going to complete the process of installing the R software for me. So I do that. I'm going to close this and install. Continue, continue, agree, continue, install. Okay? It's going to ask for a password for your computer. And when it's done, or when I enter that password, it's going to begin writing all the files and finishing the installation process. And really, that should go by very quickly. In my case, this says it should take less than a minute. Now, you can wait for this to finish, or you can also go ahead and move forward with the next step. In my case, this finished very quickly, so I'm going to say I'm done. That's it. You've now installed R, and you can go back to the slides, and you can click on the next link for RStudio. When you do that, you're taken to a website for what's now called Posit. So the company RStudio, which produced the product RStudio, as it became successful and grew, realized that they had a vision that extended beyond just a single product. So they have, although maintained the name of the product, they've renamed their company Posit. Okay, so it doesn't matter, just a bit of trivia, but you can go ahead and download RStudio here. And we want the desktop, not the server version. So I'm going to click download RStudio. And it tells you, listen, first, you should have R. RStudio can't work without R. So we've already done that. We just did that. So we're going to skip down to step 2. And it knows, it senses that I'm on a Mac system. So it only offers me the option to install the version for Mac. So I'm going to go ahead and do that. And it's going to take longer than 10 seconds. Here we say it looks like it has a minute or so left. And when that finishes, we will be all set up with R and RStudio. Now, as that's installing or downloading, I'll remind you that you can go ahead and install Sublime and Visual Studio Code. I won't demonstrate those for you, but they're going to work very similar to R and RStudio. Go to the website, download, and it'll have an installer for you. All right, RStudio should be done downloading now, so I'm going to hop back over to my web browser. Yep, it's done down here. I can click on that, and I just get a window with an application that I drag over to my applications folder. Now, in my case, I already have RStudio installed on my system, so it's asking me if I want to replace that, and you just go ahead and say, yes, replace. It's going to go ahead and copy the RStudio application over to my applications folder. And once it's done with that, we are good to go. Now, many of you listening to this video may, like me, already have some version of R and some other version of RStudio. I don't care what you have. I'd like for you to still go through the same process that I just went through, because doing what I just did is also the way you update R and RStudio. So now you know how to install them for the first time and also update them. It's the same process. And we want to make sure that throughout the course, we are all working with the same version of R and the same version of RStudio. So I'd ask that you all do this and then don't update again until the course is concluded. It'll just minimize the number of small glitches that we have associated with people running different versions of R and RStudio. Now that we have R and RStudio installed, we're ready to actually launch R. Now you could just go to your applications folder and click on the R application icon. I'm just going to search for it on my computer, and I'm going to open R, not RStudio, and this is just for demonstration purposes. So I can see the R application now here in front of me, and as we would expect, that version that we just downloaded, 4.2.2, also known as Innocent and Trusting, is the version of R that I'm currently running on my computer. But other than that, I don't have a lot of help or information here. I mean, this is a pretty intimidating user interface for someone who's just starting R. We're really left with a command prompt here, blinking, waiting for us to type some code, which is not exactly the level we're at. And even if we were at the point where we could just start writing code de novo, there's a lot that is left to be desired by this interface. For example, if I were to generate any plots or outputs, they wouldn't appear here in this window. That's not what this window is for. It's just for code. So those outputs would really be completely divorced from the interface that I have in front of me. We're going to open RStudio now. And when we do that, what you might see on your screen could look different than what I'm showing you here. And that's just because I've had RStudio installed before. It remembers some of my preferences and settings. The important bit here is that I can see in this window that this really says exactly the same thing as if I had opened the R console. It says I'm running 4.2.2 innocent and trusting, really looks identical to that R console, and that's because it is. When I opened RStudio, it opens R for me. So I never need to deal with the standalone R application ever again. I just interact with it using RStudio. I launch RStudio, I get R running in the background, okay? But you can see I have these other panels as well, and we're going to talk about those in more detail now. But what you're looking at is really that integrated development environment, this idea that we have more than just R. We have lots of ways to interact with the stuff that we're going to be doing throughout the course. And that's really where RStudio comes in. Remember, RStudio is an IDE, or integrated development environment for R, that is going to offer us more than just a console for working in the R environment. It's, as an IDE, it's really designed to maximize programmer productivity by providing a set of tight-knit components with a similar or consistent user interface. IDEs present really a single program in which all development's done. And this program typically provides many features for authoring or writing, modifying, compiling, deploying, and debugging software. So in that sense, RStudio for us brings together several different key elements: the R programming language itself, a terminal in which we can not just use R, but access other command line tools, and then a text editor that is code aware. Yes, in addition to Sublime and Visual Studio Code, you will have an additional text editor bundled into the RStudio interface itself. Of course, I just mentioned that your RStudio probably looks different. It's probably white, not dark like mine was. So I wanted to show you how to customize things in case you want your RStudio aesthetic to look like mine. Ignore that this says, another version on it. I'm just using this as a demonstration. If you click on the Edit menu item, you can see in a menu there that you have an option to select Preferences. When you do that, a pop-up window appears. You can click on Appearance, and I like a larger font. It's just easier on my aging eyes. And I like the Monokai font, and that'll give you something that looks like this. You may not like that. You're welcome to kind of click through these different editor themes and find one that suits your needs. The key thing is that the color of the font is going to match different aspects of the R code, which makes it really easy to parse out an R script and understand it. In addition to that, if you toggle on the code part of that, so we were in the appearance part of the menu, now we're moving to code, and you click on the display tab, everything here is default, except if I were you, I would also select highlight R function calls and use rainbow parentheses. These are two small things related to syntax, in other words, how the code looks or appears on the screen, that I think just make it easier and nicer to work in R. Okay, so once you do that, you should have something that looks very similar to mine, and the smaller details of the syntax that I just mentioned won't be apparent until we actually open an R script. Let's break down this RStudio interface just a little bit more. So I already described that this left-hand panel is where your R console appears, but it also happens to be where your terminal will appear. So if you notice in the upper left-hand corner, there's actually two tabs you can sort of toggle between. There's the R console, but then there's a terminal. And again, we'll talk more about this in class, but the terminal is where you can run programs that have nothing to do with R. So it's again a great example of an IDE. RStudio is giving you not just tools for working in R, the console, but also tools for connecting with other programming languages just using the command prompt in the terminal. So that's what we get in the console and terminal. We also have a workspace area here in the upper right that contains an environment tab. So any objects we create in the process of coding, whether it's a plot or a table of data, it will appear here. You can think of this as a folder of all the items you've generated in your code. We can also connect to our history and connections tabs in this workspace area. And then lastly, we have this multifunctional panel in the lower right that consists of lots and lots of important things. First and foremost, we can browse the files on our computer if we click on the Files tab, just like you would navigate your computer any other way. Any plots we generate will pop up automatically in the Plots tab. We have a Packages tab, which is the tab I'm currently sitting on, and that contains all of the R software packages that we have installed in our system all of the packages that are available to us. We're going to work a lot on packages and understanding what those are in a future lecture. We also have a very useful help tab. We'll talk about that as well. And then a viewer tab. The viewer tab is different from the plots tab in that the viewer tab is where interactive visualizations will appear. So not static plots, but things you can interact with. A scatter plot that when you mouse over it, you get information about each point in the plot. We're going to make lots of interactive graphics in the course of this class, so stay tuned for more on that. I want to take just a minute to highlight that this is a pretty interesting time for R, in part because both the R programming language and Bioconductor are, as I've described already, open source tools, but the community that uses those tools is largely interacting with them through a commercial piece of software. RStudio, made by Posit, is a commercial piece of software. It happens to be free right now and has always been, but there's no guarantee that it remains that way. So I just think this is an intriguing interaction between a commercial entity and the open source software that you access through this commercial software. And it extends actually even further than that, because a lot of the really exciting package development in R has been driven by data scientists employed by Posit that develop RStudio. So this has been a really positive interaction between a commercial entity and open source software, and we all hope it remains that way. I've already mentioned R several times without telling you anything about what the programming language itself really represents or tries to address. And so I've really kind of created this very simple schematic here of the world of R, and each of these points within this sphere represent a single standalone R package. And they're colored based on the sort of topic that they're meant to address as an R package. And so you can see there's really three main topics that many R packages deal with, and that's statistics, graphing, and modeling. And although I maybe have a few dozen points here, in reality, there are over 19,000 standalone R packages available on the comprehensive R archive network. And so with this focus on stats, graphing, and modeling, you can see why many biomedical and computational researchers felt that the R programming language represented a pretty appealing place to build out a suite of packages that could leverage statistics and graphing and modeling, but really geared towards the unique challenges of biomedical data sets. And so that's what the Bioconductor community has done. If you're interested more in understanding more about the genesis of Bioconductor, I'd encourage you to check out this 2015 Nature Methods paper. But I'm going to pull a quote from that paper that I think really nicely sums up why Bioconductor chose R. They said, "We have embraced R for its scientific and statistical computing capabilities, for its graphics facilities, and for the convenience of an interpreted language. R also interfaces with low-level languages including C and C++ for computationally intensive operations, Java for integration with enterprise software, and JavaScript for interactive web-based applications and reports." In other words, you get a lot by going with R. You get the stats and the graphics and the modeling, but you also get the ability to connect with many other programming languages. So then it follows that really Bioconductor is a set of software packages that were built within R and that leverage these pre-existing strengths of R, like statistics, graphing, and modeling. And currently, as of version 3.16, which is the version we'll install together today, there's over 2,100 of these packages in Bioconductor. And the great thing is, if you, let's say, install a Bioconductor package for differential gene expression, and let's say it needs to use some specific statistical methods to estimate differential gene expression and maybe model some error rates and produce some graphics that identify the differentially expressed genes, it doesn't need to do all of this by itself. It can leverage pre-existing stats, graphing, and modeling packages to get to that end result. And that's why we say packages in the R ecosystem are modular. They can work together. In addition to this modularity, packages within the R programming language can also be sort of chained together to form workflows. And this is a really cool way to utilize multiple packages to step through an otherwise complex multi-stage process. So for example, maybe we have a bunch of data and we have to, filter and carry out a number of statistical operations before we actually then want to carry out differential gene expression. And after we do that, then maybe we want to create some graphics that cluster our genes together so we can identify coordinately regulated genes. And then we want to take those modules and we want to carry out functional enrichment analysis. That sort of workflow can then be done by connecting the output from one R package to the input for another R package, and so on and so on. And these kinds of workflows have already been created for many different data types. So bioconductor workflows are a great way, for example, if you're starting for the first time with ATAC-seq data and you've never worked with ATAC-seq data, but you have some comfort or familiarity with bioconductor, then you can go look for the ATAC-seq workflow in R, and it's a great way to get started and understand the sort of standard packages in that niche area, how to use them, and what kind of data they need to operate properly. I would encourage you to actually think of R packages as the software equivalent of a scientific paper. And that's because they really are the de facto standard for how we communicate in R and bioconductor new findings, new tools, much in the same way that manuscripts are the standard for communicating new findings to the scientific community. R packages follow a formal and widely accepted structure. If you write a manuscript, you have to have an abstract, an introduction, a materials and methods, results section, a discussion. R packages have a similar structure. You can't just write an R package any old way you please. It has to follow this structure in order to be accepted. R packages are standalone, but they have to build on a knowledge base. In the same way you write a manuscript, you have to incorporate knowledge, previous knowledge, into the introduction to provide a context for the new findings you're going to show. The same thing applies, so to speak, for a new R package. With R packages, the target audience can vary widely and the content and quality can vary. Same way with papers. Some R packages were a one-off development that stemmed from a undergraduate or graduate research project and received little or no attention and little or no use after that individual moves on, while other packages have been under development for over a decade, have thousands of citations, and are widely used by the community. And then finally, to take this analogy of R packages equating to scientific papers to the extreme, new packages are actually often the basis for a publication. Okay, that's all great, but how do you actually get bioconductor? It's actually really easy. If you're in RStudio, we're going to paste a rather kind of awkward bit of code right here into the command prompt, and that's going to install bioconductor onto our computers. If you already have bioconductor, it will just update it. So that's the important bit here, is that you will update bioconductor using exactly the same piece of code. So if you happen to already have RStudio and R and bioconductor on your computer, I still ask that you go through this so that we, again, all have the same version of all this stuff starting off with the course. So I'm going to head over to RStudio now, and I'm going to paste that bit of code right here at the command prompt. And when I do that, I'm just going to hit enter, and it's going to ask me a few things. It's going to start essentially going through the process of installing. It recognizes that I'm going to install 3.16 of bioconductor, but immediately it stops and asks me if I want to update some old packages. So because I already have bioconductor installed, it's just going to update the packages that are out of date. And so this is a common question you'll get, is would you like to update all, some, or none, ASN? If you get that question, just always say all for A, and it's going to now go through and update all of these old packages one at a time. We're not going to wait for it to do that, but I just want to highlight that you may need to check back periodically on your installation, because you may get these questions like, do you want to upgrade some package to bioconductor version 3.16? And you'll want to say yes. Do you want to install from source the packages which need compilation? You'll want to say yes. So just be prepared. The installation may stop at multiple points and ask you some of these questions, and just respond, yeah, I want to update all. Yeah, I want to upgrade this package, yes, and I want to install from source, yes. With RStudio, and bioconductor installed, we're ready to move on to installing Callisto. Callisto is the piece of software we will use for aligning raw reads to a reference transcriptome. It has nothing to do with R or RStudio. It doesn't need or care about R. It is really a standalone piece of software that you use at the command line. And so as such, we really approach installing it a bit differently than we did for R and RStudio. We will install Callisto and a number of other tools using Conda. Now, I'm going to demonstrate that process for you just using Callisto, and I'll ask that you sort of repeat that for these other tools. But remember, if you run into issues installing these, one, we're here to help, and two, it will not prevent you from participating in the course. None of these are required. I'll demonstrate them, and that alone will be useful for you to see. But Callisto, we want to make sure that everyone has on their computer. So to begin installing Callisto or any of these other tools, we've written up a protocol that you can find on our lab website. I'm going to click on that now, and it takes us over to that page. This page is essentially a recipe that walks you through the installation of Conda-based software packages. As you look at this page, I'll just point out there's a table of contents at the top that you can click through. You can see we have a bit of a description about Conda, how to install it for a Mac or a Windows machine, how to set it up once you've installed it, some useful tips that I think you'll really benefit from reading about just using Conda in general, and then a plan B if Conda doesn't really work well for you. How do you still get Callisto if you're on a Mac or on a Windows? And then we have a number of troubleshooting tips. So you can navigate this protocol by clicking on this table of contents, and you can also just scroll. So maybe the first thing to just address is, what is Conda? So I've pulled this directly from the Conda manual. It's an open source package management system and environment management system that runs on Windows, Mac OS, and Linux, so really any operating system. It installs quickly, and it runs and updates packages and their dependencies. This is really critical because this is often where the installation of software becomes what we call a dependency hell. You can try to install something and it needs something else, and that something else needs something else, and pretty soon you have this complicated web of dependencies that really prevent you from installing what you're trying to install. And so Conda deals with that by managing that whole process for you. It easily creates, saves, loads, and switches between environments on your local computer. And although it was originally created for Python programs, to install Python programs, thus Conda, which is short for Anaconda, it now can package and distribute software for any language. Okay, so scrolling down here, the first thing is to install Conda. It comes in two flavors, Anaconda and Mini Conda. Mini Conda is the one we want to install. It's much smaller and lightweight, but yet still has all of the features and functions that we want and need, not just for this class, but I would argue for almost 90% of Conda use cases. Anaconda is much, much larger, so I would discourage you from trying to install Anaconda. So to install Mini Conda, we need to first download a small shell script. To download that shell script, you're just going to click here. And when you do that, you'll be prompted to go through and save this file to your computer, and it downloads really quickly. Shell scripts are really small. But do not click on this. It's not an executable. You can't just double click and install like we did with some of the other software. Instead, this shell script, a special kind of file that provides instructions for the installation. To actually install, we need to highlight and copy this line of code and move over to our terminal or bash or command prompt, whatever it's called on your computer. Again, I'm working on a Mac, so it's the terminal, and I'm just going to paste that in and hit enter. Doing that will begin to read the contents of that shell script and move through the installation process. It's actually really quick for Mini Conda. It'll finish and you'll be good to go. Now, I'm not going to do that because I actually already have Mini Conda installed on my computer. So I'm just going to skip that part, but you go ahead and install Mini Conda. Once you've done that, you can copy the next line of code, which is doing something called sourcing a piece of software, in this case Conda, so that it's available to you in the command line regardless of whether you're in their home directory or in your documents folder. In other words, system-wide, you'll always be able to use and find Conda. So I head over, I paste that and hit enter, and you won't see anything happen. You'll just be given another blinking prompt and it's done. You've successfully sourced that software. Now, I should just mention that this is all under the assumption that you have downloaded that shell script to your home folder. If you put it somewhere else, you would need to change this code to reflect that. So I just encourage you to put it in your home folder so that all of this code just works. The next step may not be necessary for you. It just depends on whether you're using a ZSH or other kinds of shell in the Mac operating system, but it won't hurt you to do it. So go ahead and paste that bit of code in as well. And you can see it just says no change here because essentially everything was already set up on my computer. Now, again, I'm demonstrating this for a Mac. If you have a Windows machine, I won't have time in this video to demonstrate for you, but I provided all those instructions here. We'll also, at the first lab, which is really devoted to troubleshooting and helping you with any issues you experience in the installation, we'll have a Windows person there as well. So it's not just me with giving instructions on a Mac, but you'll also have that Windows perspective. Okay, so once you've done that, Mini Conda is installed and you're ready to start interacting with Conda. And that's very easy to do. In fact, we're going to try some simple things like first running Conda info. And when we do that, we're going to see, or you should see if it's successfully installed, that running Conda info produced a bunch of information about your Conda installation, including where it's currently located. In my case, in my user home folder, there it is, Mini Conda, where the configuration file is located, what Conda version you're running, etc., etc. We can even add additional arguments, which is what this is, --envs to this initial Conda info command. And that'll tell us what environments are available to us or what environments exist on our Conda installation. When we do that, you can see that I have a base Conda environment, but I also have two others that you won't have. That's okay, don't worry. These are just two other Conda environments I use for my own work. You will probably only see the base. And actually, if you successfully installed Conda, chances are you're already sitting in or operating within that base environment. And that's totally fine. Okay, so one of the great things about Conda is that it has access to lots and lots of software through these various what are called channels. And so we want to start off by configuring your Conda installation so that it knows which channels to look at, the default channel, BioConda, which is a channel that, as the name suggests, contains a lot of bioinformatics software, Conda Forge, and we want to make sure these channels are never taken offline for us. So I head back over to my terminal, I paste these in, and I hit enter. And it basically says, we're good here. Everything's largely configured the way I wanted it to be configured. You may have a slightly different message here, and if you do, that's fine. With Conda already installed, configured, set up, and ready to go, we are now ready to use Conda to install Callisto. So if we scroll down, we're now ready to create our first Conda environment. To do that, we're going to copy this command. We're going to head over to our terminal again. We'll paste that in. And what we're running here is we're telling it we want to run Conda, and we want to use this. So we always start by calling the program we want to use, and then the function create, and then arguments that specify exactly how we'd like that function to behave. We, in this case, want to create an environment with the name RNA-seq. Now, I've chosen this name. You could choose whatever name you want. I encourage you to just choose this name so that there's no confusion as you follow along later in the course. But when we do that, it's going to say, okay, listen, I'm collecting some metadata, I'm fixing or creating the environment, and when it finishes, it will have created this new environment, an empty one, but an environment nonetheless, and it's an environment that's called simply RNA-seq. And it says, listen, I'm going to install, create this environment. I'm going to create it here. Is that okay? In other words, it's giving the location. And you just want to say Y for yes and hit enter. And it's done. And it provides some helpful information here like, hey, if you run conda activate RNA-seq, it'll turn on that environment. And if you want to turn it off, you could say conda deactivate. And that's really helpful. In fact, if I do conda activate, help if I spell it right, RNA-seq, and I hit enter, now I can see that I switched from this base environment to the RNA-seq environment. What I've effectively done is I've created a software silo that exists connected to my operating system, but really distinct from or separate from all other software on that operating system. And that means that I can install a piece of software that, for example, needs Python 3.1, and have it sitting right on the same computer as another piece of software sitting in a different environment that needs Python 2.5. So they both could use totally different versions of Python and coexist on the same computer. And so these software silos are meant to be a solution for the otherwise complex issue of trying to deal with dependencies that different pieces of software need to exist on a computer. Okay, so I could run that next bit of conda deactivate, and it will return me back to that base environment. Okay, so it's that simple, really. That's how we create an environment. That's how we enter the environment and then leave it. Now, right now, that software silo called RNA-seq is completely empty. It has nothing in it except sort of basic elements. So now we're ready to actually move down and install Callisto in that environment. So first, I want to conda activate RNA-seq. And hit enter. We want to make sure, whoops, I spelled that wrong. This is a good, a good tip. Anytime you want to go back to a previous command you ran, we successfully ran that command earlier, you can hit the up arrow and key up, 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 and go as far up as you'd like in your history of commands and hit enter. And now we're back in that RNA-seq environment. It's really important, this step, that you make sure you're in your RNA-seq environment, because we don't want to accidentally install Callisto in our base, or else things start to get confusing. We think software is in one silo and it's actually in another. So make sure you're in RNA-seq. And now we're ready to copy and paste this bit of code and install Callisto. It's now going to go get Callisto from Conda, and it says, well, listen, I'm going to get Callisto, but there's a bunch of other stuff that Callisto needs to work, dependencies. Are you okay with me installing that? And you say yes, because I know it's going to only install those things in that silo that I made. And if I ever want to get rid of all this extra stuff, I just delete the RNA-seq Conda environment. That's now done. I now can type Callisto, and I can see that, oh, there it is, Callisto 0.48. And I can see that Callisto has a number of functions that I can run. The software is successfully installed, but it only exists in that environment. And so we can test that. We can actually type conda deactivate, go back to our base environment, and now type Callisto. And we see it doesn't even see it. It's as if it doesn't exist on this computer. We know it does. We just now understand that these conda environments really are silos. They're really independent. And we really need to be, and I'm going to just key up to get that command, we really need to be in that RNA-seq environment in this case in order to access this piece of software. Okay? We have Callisto installed. We're ready to move on. Of course, as I say here in the protocol, if you type Callisto, you'll get an output that tells you the version you're running and gives you the details I showed you just here in the terminal. So now you're ready to rinse and repeat. We're going to install more software inside that same RNA-seq environment. We're not going to create separate environments for each piece. We're basically making an environment using Conda that has a bunch of tools that we'll use for this one thing, RNA-seq data analysis. So I'm going to take this next line of code, which again is just using Conda to install FastQC, a program, and it's going to fetch FastQC from the BioConda channel. And I'm going to head over to the terminal, paste that in, and hit enter. And it'll take just a minute. Again, it's asking me if I want to install software. The answer is always yes. And I can see that it's taking a while to install this piece. This is actually a Java development kit. And that's because FastQC actually needs to launch, depending on how you want to use it, needs to launch a graphical interface, and that requires Java. So that's taking just a second. While that's finishing up, I'm going to grab the other bit of code that does essentially the same thing, but installing another tool. Again, we're not talking about what these tools do just yet, but we will talk in detail about them. And this one's going to be multi-QC. So it's done. I can now install the next bit. And again, each of these, FastQC, multi-QC, Callisto, they're all ending up in the same Conda environment, RNA-seq. And so again, it's creating the software in that environment, and that may take just a second. Let's see here. Okay, while that's going, remember, if you have problems with any of this, we'll be there to help you for the lab. And I have lots of other sort of plan Bs and backup plans in case that, that continues to cause you problems. So this can sometimes take a while. It can be stuck on solving environment. It can even, as you see here, fail with an initial frozen solve. So we'll give that just a minute to finish. Okay, that took just a couple minutes to finish, but it's a good example of why Conda is so great, because it clearly ran into issues installing multi-QC. It managed those issues, resolved any conflicts it had, and it's done now. So I'm just going to clear my terminal and everything is ready for the next part. I have multi-QC, fast QC. In fact, I could type fast QC, which is one of the pieces of software I installed, and it'll actually launch a program. Okay, now we can interact with FastQC using this program, but we can also use the command line and use FastQC to analyze raw sequence data for quality assessment. It's just an example of how we've put a piece of software into this Conda environment, and it's available to us, just like Callisto. So at this point, you're going to move through the rest of this tutorial, and you're going to finish installing the rest of the software. In this case, the next thing you're going to do is install KB, which is Callisto Bus Tools. We'll use it for single cell data at the end of the course. Only copy the bit of code I have here, not the comments I've put out past the hash mark, and move through and try to create that new Conda environment, activate it, install the software you want, and then test that it works. So that's the kind of routine we go through. Create an environment, activate, install something in it, and then test that it works. Remember, make sure you're using the right environment. Make sure you're not accidentally installing this, for example, in the RNA-seq environment. If you choose, you can set up different environments for every piece of software you set up, but I've given you instructions on how to, or how I suggest you do this here. That's it. Good luck installing, and if you have any issues and you're around, show up at the lab and we'll help you resolve them.